Let's see how we can calculate the angular momentum of a two-particle system. Let's consider a system of two particles that move in space. Particle number 1 has linear momentum of 5 kilograms meters per second and a position vector r1. This particle passes 2 meters from the origin, which is at point O. Then particle 2 has momentum of 2 kilograms meters per second, and its position is given by the position vector r2, and passes 4 meters from the origin at point O. So what are the magnitude and direction of the net angular momentum, L, about that point O of the two-particle system? So here is particle 1 with momentum P1 and position vector given by R1. And so the line along which the particle trajectory lies is a distance 2 meters from the origin of the coordinate system. So this distance is labeled with r perpendicular 1. For particle 2 with momentum P2, the position is given by the position vector R2. And so the line along which the momentum vector lies for particle 2 is a distance r perpendicular 2 from the origin of the coordinate system, and that is equal to 4 meters. To solve this problem, I'm going to use one of the results presented in the lecture presentation, and that was that the angular momentum is equal to the product of r perpendicular times p. The angular momentum for the first particle, L1, is going to be equal to r perpendicular 1 times P1, which is 2 meters, times 5 kilograms meters per second, and that is equal to 10 kilograms meters squared per second. For the second particle, the angular momentum L2 is equal to r perpendicular 2 times P2, that is equal to 4 meters times 2 kilograms meters per second. This is equal to 8 kilograms meters squared per second. To find the net angular momentum of the system L, I simply must add the two vectors L1 and L2. However, here I must account for the direction of each of those two angular momenta with respect to the origin, because when I calculate this sum, the direction of each of those will determine how I add them together. So if you go back to the drawing provided for the statement of the problem, the plane here in which those four vectors lie is the xy plane, and the z-axis is coming straight out of the page towards us. So that is consistent with a right-handed three-dimensional coordinate system, and I'm going to use that orientation in order to determine the directions of the angular momentum of each particle using the right-hand rule. Let's look at particle 1 first. So the position vector r1 is directed like so in the xy plane. The momentum vector is directed like so in the xy plane. I'm going to slide the momentum vector so that both vectors have the same starting point. They both start at the origin, and then I will apply the right-hand rule. The right-hand rule states that if I place the fingers of my right hand along the direction of R and rotate the one towards P, then the thumb of my right hand is going to point in the direction of the resultant angular momentum vector. So the angular momentum vector is going to be along the positive z-axis coming out of the page towards us. This means that when I'm calculating the total angular momentum of the system, I'm going to take the value of the angular momentum of particle 1 with a positive sign. For particle 2, the position vector r2 points like so, and the linear momentum vector p2 points like so. Again, I'm going to slide p2 so that both r2 and p2 have the same origin at O. And then I will apply the right-hand rule to determine the direction of the angular momentum vector for the second particle. According to the right-hand rule, if I place the fingers of my right hand in the direction of R2 and then rotate towards P2, the thumb of my right hand determines the direction of the angular momentum vector, and so in this case the angular momentum vector will be into the page. So into the page, away from us, that is L2. So that means that when I'm calculating the total angular momentum, I'm going to take the value of L2 with a minus sign. So adding the two values for the angular momenta L1 and L2, 10 kilograms meters per second plus minus 8 kilograms meters squared per second. The final result for L, I get 2 kilograms meters squared per second. So the orientation of that angular momentum, the angular momentum of the entire system of two particles will be in positive z direction or out of the page.